Hello everyone, welcome back to the LeetCode 75 study plan series. Today we are going to be doing our second prefix sum category problem. It's gonna be called Find Pivot Index, and it's ranked as an easy problem. So yeah, let's go ahead and dive right into it. So for the instructions, we're given an array of integers nums. Calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all of the numbers strictly to the index's right. If the index on the left edge of the array, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. Return the leftmost pivot index. If no such index exists, return -1. Okay, so these instructions are pretty clear in my opinion. Basically, we have to calculate the sum of what's on the left of the pivot and then what's on the right of the pivot. And if they equal each other, then we return that index. So in this case, the pivot is index 3. So since we have a 0 index, the pivot is going to be 6. So this is 5 plus 6 is 11, and then 7 plus 3 plus 1 is 11 as well. So then we return the index of 6, which is 3. So I hope that you guys understand what the problem statement is, and then let's go ahead and go into the implementation for it. So what we need to do is essentially create a total sum and a left sum variable. And basically what we're going to do is we're going to have two for loops. In the first one, all we're going to have to do is get the total sum of all the numbers in the array, and then we're going to be slowly subtracting those numbers off and checking if it's equal, if both sides are equal. So that's why it's a prefix sum category, because we're using the basically subtraction from the total sum as sort of a prefix. So anyways, let's go ahead and mark this total sum equal to 0. And then in the same statement, we can just do a left sum equal to 0 as well. And then we can just use a for each loop to iterate through and add all of the integers in the array. So int nums and nums, and then basically just total sum plus equal to num. And then what we want to do now is go through our second for loop, and then this is just going to be a standard for loop starting with int I equal to 0, and then we're going to iterate through the whole array length, and then plus plus. All right, so our conditional statement first is what we want to check if so we have to check if the left sum is equal to the total sum minus the left sum minus the number at index I. So remember that we're not including index I as part of either side. It's just the left side and the right side. And the right side is going to equal the total minus the left sum minus the number at index I. So if both sides equal each other, then we need to return I, which is going to be the index which the pivot is located at. So if left sum is equal to left sum minus, it's going to be, sorry, my bad, total sum minus left sum minus nums at index I. And then if they're equal to each other, then all we have to do is return I. And then if they're not equal to each other, what we need to do is add that number at I, the supposed pivot number, to the left sum. And then we're going to move on to the next one and check again. So left sum plus equals, and then nums at I. Okay. And then what happens if we don't find a pivot number where the left side is equal to the right side? Then we have to return -1, and we can see that in example 2 right here. Since there's no index that satisfies the conditions in the problem statement, we just return -1. So that will be the case if we get out of this for loop and don't return anything. So all we have to do is type in return -1. All right, let's go ahead and run this. Okay, cool. So we got the first three test cases accepted. We'll submit this. All right, there we go. Runtime of 1 millisecond beats 100% of the solutions. You can see this is a fast optimized solution. And then let's go over the time and space complexity. For the time complexity, it's just going to be big O of n because we're just iterating through. Well, we iterate through twice, but it's basically 2 times n, which still counts as big O of n. For those of you who are familiar with big O time complexity. So it still has a time complexity of big O of n. And then for the space complexity, it's just going to be constant space complexity, big O of 1, because we don't use any data structures that scale with the input size. So there you have it. That's the find pivot index problem. And that is the last of the prefix sum category problems in the LeetCode 75 study plan playlist. So I hope you guys enjoyed it, got a better idea of how this category works and how this particular problem works if you come across it in an interview. I hope it helps you. And yeah, so if you found this video helpful, please make sure to like it and subscribe for more related content. And as always, I'm open to suggestions. Just leave those in the comments for me. All right, we'll see you in the next one.